address resolution protocol is one of the fundamental, the most important protocols when we talk about the data link layer. We have learned about the IP addresses in the network layer, which are 32-bit addresses. We have also learned about the 48-bit MAC addresses, which are the addresses corresponding to the data link layer. What the address resolution protocol does is basically mapping the IP addresses to the MAC addresses. Since a host has the IP address assigned to the network layer and the 48-bit MAC address, which we have defined previously, then there is a need for a protocol which basically maps these two in order to understand to which equipment which address corresponds to. When we talk about MAC addresses, the address allocation is administered by the IEEE, and since it is an address of 48 bits, there is a part which identifies the manufacturer, and then there is a part which identifies the network interface card. What is characteristic about the MAC addresses is the portability, meaning that traditionally these addresses are fixed, meaning that each of the equipment has its assigned MAC address, which typically does not change. So the fact that we go from one local area network to another local area network, the MAC address would remain the same. However, the story is not the same for the IP addresses, because the IP addresses are not portable, meaning that the same equipment going from one local area network to another local area network could be assigned a different IP address. It's true that in today's world, also the MAC addresses can be set by software, so there is certain evolution. But in principle, the MAC addresses are, let's say, fixed, whereas the IP addresses are addresses that change over time. And what the address resolution protocol does is, in fact, doing the mapping between the IP address and the MAC address. The equipment, in this case the computers, have their corresponding ARP table in which they have information about the IP address, about the MAC address, and the time to live. So each of the equipment will have a corresponding IP address, and the actual equipment or apparatus will have its corresponding MAC address. So what ARP allows us to do is to do the mapping between the two, such that if there is a, let's say, a communication between this equipment with another equipment connected through the LAN, then they are able to identify one another. The type of messages which allow to do this type of mapping in order to populate the ARP table are called ARP messages. And the message format that we see is somewhat very similar to what we have seen in previous layers, in previous lectures. Basically, there is information on the hardware type. You see that there is information of 32 bits. So there is information on the hardware interface, that there is information on the protocol type, the hardware length, so basically the length of the MAC address, the protocol length, so the length of the IP address, and so on. And then there is the operation. This is important because it identifies whether the type of message which is being sent using the ARP protocol is an ARP request or is an ARP reply. What does it mean to send a message which is an ARP request or an ARP reply? We consider this simple connection between two equipment in which each of them has a IP address and a MAC address. The idea is that the router, in this case here, knows the IP address but does not know the MAC address of the computer. So in this case, what the router does, it sends a broadcast message on the data link layer. So this type of message is the ARP request, so referring to the previous slides. In this ARP request, the type of content of the message is such that the source address is the one which corresponds to the MAC address of the source. So we see that the MAC address of the router matches the source address of the message which is being sent. And the destination address in this case is F, as we have defined before. When the type of message is broadcast, then the MAC address, all the bits in the MAC address are equal to 1. This, translated in hexadecimal format, means that having a 48-bit message or address denoted as F in hexadecimal format. Once the computer, once the equipment has received this type of message, if the IP address matches the IP address of the message which is being sent, then it will reply with a type of message which is identified as ARP reply, which is a unicast message. In this case, putting as the source address, SA, the MAC address of its own. So the MAC address of the equipment which is responding, in this case, matches the source address. Keep in mind that now the destination address exactly matches the destination address of the router. This is a very simple example of just two equipment. We can, in the same way, imagine scenarios in which there are more than one equipment connected to this network. And in this case, if there were any other network or any other equipment connected to this network, then when we talk about the ARP request, they would drop this request because their IP address would not match the IP address which is indicated in the ARP request. And it would only match with the intended equipment, which in this case we have identified through IP address and the MAC address. Here we're also showing a series of steps which are taken in order to do the address resolution. As the name suggests, ARP stands for Address Resolution Protocol. So the host, or the router in this case, will send a message towards the host, B. In this case, the MAC address of B is not in the ARP table of A. The first message that is sent is a broadcast message. So the ARP query is a broadcast message in which the MAC address which is specified is 48 bits equal to 1. And then when the station B will receive the ARP query, it will reply with its own MAC address. And once the router has received the MAC address, it will insert it in its ARP table. And this way, it will learn how to do the mapping between the IP address and the MAC address of the equipment that are present in its network.